Hey everyone, this is part 2 of polynomial addition and multiplication. In the last video, we ended with this slide, and today I'm going to demonstrate how these types of problems work. So, we'll introduce the FOIL method. FOIL is an acronym that stands for first, outer, inner, and last. This is a good word to remember because it helps you remember the order in which you are supposed to multiply certain terms. Once that multiplication is done, we add everything together. So consider the polynomial ax plus b times the polynomial cx plus d, where a, b, c, and d are some real numbers. So we're going to multiply each term in the order of FOIL by locating the first, outer, inner, and last terms of the quantities in question. So when I say the first terms, I'm referring to the leftmost terms in each quantity. In our case, that's ax and cx, so we simply multiply them and place them below. The outer terms are ax and d, so write ax times d below. The inner terms are b and cx, so write b times cx below. And then the last terms are b and d, so write b times d below. And then we just add everything together. After some simplification, we get ac x squared plus adx plus bcx plus bd, which simplifies to ac x squared plus the quantity ad plus bc times x plus bd. I know it looks like there might be a lot going on here, and the letters definitely don't help, but simply remembering the word FOIL helps you remember the order in which you are supposed to multiply the terms. The FOIL method is a very useful technique, but it can only be used if the polynomials being multiplied each have two terms. Here, ax plus b has two terms, and so does cx plus d. Okay, let's look at some examples. Oftentimes the word FOIL is used as a verb, but that just means multiply polynomials by using the FOIL method. Multiply the polynomials x plus 1 and x plus 2. First things first, we need to multiply the first terms. In our case, that gives us x times x. The other terms give x times 2. The inner terms give 1 times x, and then the last terms give 1 times 2. In the next step, we simplify to get x squared plus 2x plus x plus 2, and then combining like terms gives us a final answer of x squared plus 3x plus 2. So once you drop the letters, this isn't too bad of a process because things tend to simplify and condense to a nice answer. But practice makes perfect, so let's do another example. Consider the multiplication of the polynomials 3x minus 1 times 2x plus 5. Just like before, locate our first terms, which give 3x times 2x. Our outer terms give 3x plus 5. Our inner terms give minus 1 times 2x. And then our outer terms give minus 1 times 5. There is a minus 1 here in this first quantity, and you have to make sure that you're paying attention to negatives. Dropping negatives will result in an incorrect answer, so in this multiplication process, every time you see a minus, bring that negative sign along with the multiplication. The hard part's over, so simplify to get 6x squared plus 15x minus 2x minus 5. Combine like terms to get a final answer of 6x squared plus 13x minus 5. We'll do a few more examples using the FOIL method, but we'll make the examples look a little bit more challenging. It's going to be the exact same process, we just have a little bit more simplification to take care of. In this first example, let's multiply the polynomials 3x squared plus x and 5x to the fourth plus 2x squared. Going through, we see our first terms give 3x squared times 5x to the fourth. Our outer terms give 3x squared times 2x squared. Our inner terms give x times 5 to the fourth. And our last terms give x times 2x squared. Using the order of operations, we get the following. Then taking care of the exponents, we get 15x to the sixth plus 6x to the fourth plus 5x to the fifth plus 2x to the third. And rearranging the terms so that the powers are written in descending order, we get a final answer of 15x to the sixth plus 5x to the fifth plus 6x to the fourth plus 2x to the third. This is just standard convention to write our powers in descending order. So the FOIL method was used just as it was in the previous slide. We just had a few more terms to simplify, but other than that, the process was the same. Now, let's look at the next example. Multiply the polynomials x squared minus x and minus 3x squared plus 1. Since we have negatives in the picture, we have to be careful that we are preserving the correct signs. Carrying out the FOIL method, we locate our first, outer, inner, and last terms, and then we simplify to get the following. At the end of the day, we get a final answer of minus 3x to the fourth plus 3x cubed plus x squared minus x. The last topic we cover in this video is another type of polynomial multiplication. This particular process actually does not allow the FOIL method, seeing as how one polynomial has 2 terms and another polynomial has 3 terms, just like in this example where we were asked to multiply x plus 1 times x squared plus x plus 1. I'll write it again here, and at the end of the day, I hope I have convinced you that we are just going to use the distributive property twice. So, take the entire quantity x plus 1 and distribute it to each of the individual terms in the polynomial x squared plus x plus 1. So, take the quantity x plus 1 and multiply it by the first term, x squared. Next, take the quantity x plus 1 and multiply it by the second term, x. And then third, take the quantity x plus 1 and multiply it by the third term, 1. We can't add everything together just yet. We still have some more distribution to do. So look at the first term, quantity x plus 1 times x squared, and distribute the x squared across the quantity, like so. Do the same thing again and distribute x across the quantity x plus 1. And then lastly, distribute 1 across the quantity x plus 1. Now we can simplify and add everything together. This will give us a final answer of x cubed plus 2x squared plus 2x plus 1. That might have seemed like a lot to bite off here, but really what we're doing is using the distributive property twice. Once in a larger scale and then once on a smaller scale. So once you've mastered distribution, you're good. We'll look at some more examples for some more practice. In this example, we're going to multiply the polynomials 2x squared plus x and 3x cubed minus x plus 2. We'll distribute the smaller quantity, 2x squared plus x, across a larger one. So we do it term by term. 2x squared plus x times 3x cubed looks like the quantity 2x squared plus x times 3x cubed. Next, we'll have to distribute the quantity 2x squared plus x onto the next term, which is negative x. Pay attention here because there is a negative, which means that that negative has to be preserved. So we do it in the following manner. Write it just like this, 2x squared plus x times negative x encased in parentheses. Remember, parentheses are your friend. Even though it looks like the work is getting pretty busy on the page, it helps you keep track of negatives and ensures that you get the correct answer. Last, we'll distribute the quantity 2x squared plus x onto the term 2, because that's the only one left. And that looks like 2x squared plus x times 2. Now that that's done, we're ready for our second round of distribution. Distribute 3x cubed onto the quantity 2x squared plus x to get 2x squared times 3x cubed plus x times 3x cubed. Do the same thing with the next term. Negative x distributes onto 2x squared plus x and gives 2x squared times negative x plus x times negative x. Lastly, distributing the 2 along 2x squared plus x gives 2x squared times 2 plus x times 2. Simplifying further gives 6 times x squared times x cubed plus 3 times x cubed minus 2x cubed times x minus x times x plus 4x squared plus 2x. And then simplifying further, which seems to be our favorite thing to do here, gives 6x to the fifth plus 3x to the fourth minus 2x to the third minus x squared plus 4x squared plus 2. And then we just combine like terms to get a final answer of 6x to the 5th plus 3x to the 4th minus 2x cubed plus 3x squared plus 2x. Polynomial multiplication is a pretty tedious process. It is a good thing to practice on a regular basis because in a time setting like an exam, if you're not practicing, it is easy to run out of time, make simple mistakes, and get problems wrong. So definitely practice. It is really easy to find all kinds of exercises online or in a course textbook.